Hi everybody, welcome back to another algorithm problem.
Hi, Future Michael here. So I'm currently editing this video, and I realized that it's been about 6 months since I posted my last video, and a lot has been going on in the last 6 months. TLDR, moved across the country, switched jobs, and I haven't really had time to edit videos these days. I have a bunch of videos that I filmed like 4 or 5 months ago. Even this video was filmed like 4 or 5 months ago, and I haven't really had time to edit them. Anyway, a bunch has been happening in the last 6 months. I'm really sorry I haven't really got around to post videos, but I will try to do that in the next couple of weeks. Also, let me know if you want to see something like a live update video. Frankly, I don't think you guys care, but if you do, let me know down below in the comments, and back to the video.
Today we're going to solve LeetCode 328, odd, even, linked list. This question feels like an easy problem, and frankly it could be an easy problem depending on the way you want to solve it, also depending on the input and complexity constraints. So the question says, given the head of a singly linked list, group all the nodes with odd indices together, followed by the nodes with even indices, and return the reordered list. The first node is considered odd, the second node is even, and so on. So this question gives you a linked list with odd and even indices, and you should group all the odd indices together and even indices together and connect the two groups so the odd indices come before the even indices. This problem is similar to one of the problems we have on this channel, which is to partition a linked list. I'll put the link below in the description and on the screen if you want to check it out as well. While that question wants you to partition a linked list around a certain pivot value, this question wants you to partition a linked list between odd and even indices. So we're going to cover two solutions, the easy one and the hard one, and I'll write the code for the hard one because the easy one is pretty trivial. So let's get into it. So here's an example of a linked list that we have. We have an input of 1, 2, 3, 4, 5 right here, and then we have an output of 1, 3, 5, 2, 4. So the nodes in red are odd nodes, and the nodes in green are even nodes. These are even, and these are odd. 1, 3, and 5. And then we should group all the odd nodes together. And as you can see in the output, we just group them 1, 3, 5. And then we just group the even nodes together 2 and 4. And we have to make sure that the order in which the nodes appear, like 2 comes before 4. So 2 should also come before 4 in the output. And then also for the odd nodes, 1 comes before 3, 3 comes before 5, and then in the output, 1 should come before 3, should come before 5. So that's pretty much what the question wants us to do. Group odd and even indices of a linked list in the order in which they appear. The first node is considered odd, the second node is considered even, and so on. And what we want is to partition these nodes so the odd nodes are pointing to each other in the correct order in which they appear, and the even nodes are doing the same, and join these two partitions together like so. The first solution is the suboptimal one, and that is to iterate through the linked list and add even indices to like separate array list and odd indices to separate array list, and reconstruct those two linked lists and join them together at the end. We'll have a counter that tells us which node is even and which node is odd, depending on the index, and then we would just reconstruct the two linked lists consisting of odd nodes and even nodes, and then join those at the end. So let's see how that would work. So we have our linked list with values 1, 2, 3, 4, 5, and then for our first solution, we're going to iterate through the list and then add the even nodes to like an array list and the odd nodes to an array list. And we're going to have a counter variable that tells us which index we're currently iterating at, if it's an even index or like an odd index. And this is going to be like cookie cutter linked list iteration with a while loop that says while head is not equal to null, and then in the while loop we can say head is equal to head.next, and then we can also increment like a counter variable, like counter is equal to counter plus 1. And for the first time that we're going into the loop, we're going to initialize a counter to 1. So now our counter is 1, and then we're iterating through this list. First of all, we're going to be at the first node, which is 1, and then we check, is 1 an even index or an odd index? Turns out 1 is an odd index, so we add 1 to like an odd array list or an array, whichever one works for you, as long as you're keeping track of them. So I'm just going to say odd, and then we add 1 to it, that's the value at index 1 and not the actual 1. It just turns out that this corresponds exactly with the indices, like the value at each index corresponds exactly with the index's value, but that's not what's going to happen in every case. So what we want to do is not add the index itself to the array list, but add the value at the index. The value is 1. That's what we're going to add. So then we move on to the next iteration, increment the counter. So now our counter becomes 2. This is going to be really messy. 2. And then we check, is 2 an even index or an odd index? Turns out 2 is an even index, so we add 2 to the even array list. So that's 2. And then we move into the next iteration, increment the counter. So now counter becomes 3. And then we check, is 3 an even index or an odd index? 3 is an odd index, so we add the value at index 3 to the odd array list. So 3 comes here. And then we move on to the next iteration, incrementing the counter as we go. So counter now becomes 4. And then we check, is 4 an even index or an odd index? Turns out 4 is an even index, so we add the value at index 4. Value at index 4 is 4, so we add 4 to the even array list. And then we move on to the next iteration, incrementing the counter as we go. The counter now becomes 5. And then we check, is 5 an even index or an odd index? Turns out 5 is an odd index, so we add 5 to the odd array list. So now what you're going to find out is, we're not done yet. We're also going to go to the next iteration, because our iterative algorithm, like our while loop, doesn't know when to stop unless we come across like a null node. And then we move into the next iteration, incrementing the counter as we go. So now counter becomes 6. So the very last node will be pointing to like a null node. So 5 would be pointing to null. And then we're going to go to the next iteration, incrementing the counter as we go. And then we come here, and then we check, are we at a null node? Is the pointer currently pointing to a null node? Which it is. So if that's the case, then we just break out of the loop. So breaking out of the loop, after we do that, we're going to find out that we're going to have 2 lists. One list consisting of odd values, and the other list consisting of even values, or rather values at odd indices and values at even indices. So we're going to reconstruct 2 separate linked lists with these values and then join those linked lists together. So the first one would be connecting 1, 3, and 5. And then we reconstruct another linked list with the values at even indices. So that would be 2 and 4. So 1 connects to 3, 3 connects to 5, and then 2 connects to 4. So we're going to have 2 lists, 2 linked lists. Now all we have to do is to connect the tail of the odd list to the head of the even list. So at the end, we're going to have the values 1, 3, 5, 2, 4, which is the final answer. This is a valid solution, but it's super expensive on space, and the constraints say the linked list could have up to 10,000 elements. So we want to find some solution that doesn't consume extra memory and can be done in place. And the next solution does just that. The second solution is more optimal and doesn't use additional memory. So how does it work? We're going to iterate through 2 lists at a time, and we're going to update the .next pointers as we go. So one list would contain values of even indices, and the other list would contain values of odd indices. The 2 main differences with the first solution are, 1, that we're not going to keep track of a counter variable that tells us which index is even or odd, because the decision about whether an index is even or odd is binary. If it's not even, it's got to be odd, and nothing else. And because we know that the first node is odd, then the next node must be even, and the next is odd, and the next is even, and so on. So we don't really need to keep track of a counter variable. The second difference is that we're not going to store the values of even and odd indices in an array list or some other data structure. So let's go through an example to see how the solution works. We're going to initialize 2 lists. Let's call them odd and even. This is odd, and this is even. Right off the bat, we know that the first node is odd and the second node is even. So first node's odd, second node is even. So the head of the odd list would be the first node, as you can see, and the head of the even list would be the second node. So even list starts with the first even index, and the odd list starts with the first odd index. And now we're going to iterate through these two lists, odd list and even list, and we're going to do 4 operations. And the order in which we do those operations is really, really important. First, we're going to set odd.next to be even.next. So I'm talking about while we're iterating through those two lists in a while loop. In the while loop, we're going to do 4 operations. First operation, we're going to set odd.next to be even.next. And next, we're going to update odd to the new odd.next that we just updated in the previous step. Then, we're going to set even.next to odd.next. And finally, we're going to update even to the new even.next that we just updated in the previous step. I know that sounds confusing, but I promise you it's going to make sense in a second. So let's dive into an actual example going step by step of how this process works. So let's say we're iterating through these two lists, iterating through the odd list and the even list. And this is the head of the odd list, this is the head of the even list. First, we're going to check if odd.next is not equal to null and even.next is not equal to null. So let me do that. This would be pointing to null, and this would also be pointing to null at the end. So odd.next is not equal to null for now. Even.next is also not equal to null for now. So we can continue doing the 4 operations that I just mentioned. First one is we're going to set odd.next to even.next, which means that we're going to move this pointer and point it here. So odd.next points to even.next. So when we do that, we've essentially blocked the connection between 1 and 2. 1 now points to 3. So let's erase the connection between 1 and 2. Now we have to update which odd value we're going to next. Logically, the next odd value that we should go to is 3. So we're going to set odd to the new odd.next that we just updated. I think it's better if I just put something on top of them so we could keep track of which one's odd and which one's even. So I'm going to do O for odd and E for even. So now the current odd pointer points to 1, current even pointer points to 2. We're going to move the current odd pointer to point to 3 now, which is the new odd.next that we just set. So let's do that. Odd now points to 3. And next, we're going to set even.next to be odd.next. So even.next, which is this one right here, we're going to move that pointer to be odd.next, the new odd.next that we just set. So let's do that. Even.next points to odd.next. This means that we've essentially erased the connection between 2 and 3. So there is no connection here. Let's erase it. Next, we set even to the new even.next that we just updated. Logically, the next even is 4. So we move the even pointer. Now goes on to 4. Now we're ready to go to the next iteration of odd and even. So we do the same 4 operations again. First operation, set odd.next to even.next. So odd.next, which is 3 pointing to 4. Now even.next is 5. So let's do that. Odd.next goes to even.next, meaning we've erased the connection between 3 and 4. And then we can set odd to the new odd.next that we just updated. So odd, which is 3, now goes to 5. And then we do the same thing for even. Even.next now becomes odd.next, the new odd.next that we just updated. Notice that odd.next points to null, which is fine. It's totally fine for now. So we're going to point even.next to null. So even.next points to null. And then we can move even to the new even.next that we just set. even moves on to even.next. And now we can erase the connection between 4 and 5. So this has been updated. And also 5 and null has been updated. So this connection is no longer there. So now what you can see is that we're ready to go into the next iteration. But the constraint to go into the next iteration is if either like odd.next is equal to null or even.next is equal to null. And in this case, they're equal to null. So now we're going to break, which means we're going to break out of the while loop and we're done constructing two separate lists, two independent lists of odd values and even values. Let's see what we just did here. So as you can see, 1 points to 3, 3 points to 5, and then 2 points to 4. So now all we have to do is to connect the last value in the odd list, the last element in the odd list, to the first element in the even list. So now we just connect 5 and 2. It's going to be messy if I do it here, so I'm just going to move everything up a bit and then write it at the bottom. So we've got 1 pointing to 3, 3 pointing to 5, and then we've got 2 pointing to 4, and then 4 pointing to null. And now we just have to connect 5 and 2. This is the bridge that we're going to make here that connects to two lists. And this is the final answer. So if you were in an interview setting, it's highly unlikely that you would think of the second solution, but that's okay. If you have a working solution, you could discuss more optimal solutions with your interviewer, as long as you have an idea that your solution can be optimized, and you could talk about like potential optimizations with your interviewer, even though those potential optimizations may not be fully fleshed out. It would be like a conversation starter, and you could talk about more, computer science-y things in the interview. And that's really important to have that like back and forth conversation with your interviewer, and that gives them a sense of how deep your knowledge of computer science is. So don't beat yourself up if you don't come up with like a super optimal solution. What you should try to do is come up with a working solution, like a brute force solution, and then try to optimize it as you go. You may even go for another solution that's right in the center of these two solutions that we just discussed. You can use the two-pointer runner technique and have two runners, a fast runner and a slow runner, going through the same list. So while iterating through the linked list, you're going to have fast runner and slow runner going through the same list. The fast runner moves 2 steps at a time, and the slow runner moves 1 step at a time. So the slow runner would point to odd nodes, and the fast runner, since it moves 2 steps at a time, it would point to even nodes. Then you can create a new node at every instance of the fast and slow runners, maintaining the two lists as you go, and join those two lists at the end. So this strategy is explained in detail in the partition links list question that we have on this channel. I'll put a link in the description or on the screen, and I highly recommend you watch it to learn more about this type of solution. The runner technique is super important in solving links list question, so you should definitely watch that video. So let's talk about the time and space complexity of this solution. So for time complexity, we're going through every single node in the linked list. So time complexity is going to be O of n. So T is O of n. And then for space complexity, we are not storing extra space, so space complexity is going to be O of 1. So yeah, that's how you solve this question, guys. Let's dive into the code. Alrighty, so the first thing we're going to do is have an edge case that checks for if the head is equal to null. If this is the case, then we just return null. So with that out of the way, let's initialize the two lists, the odd and even list. So let's say list node, odd would be pointing to the first node in the list, which is the head, and then we have another list node called even, which would be pointing to the second node in the list, which is head.next. Now you see why it's important to have this check here, because if head is null, head.next would give you a null pointer exception, and you don't want that. So now we're going to have like a third list, and this is important so we can create that bridge at the end that connects the even and odd lists. So let's have another list node, let's call it even head, and that will just point to even. So now let's iterate through the two lists that we have here. So let's say while even is not equal to null, and even.next is not equal to null. Let's do stuff. So if you're wondering why I did even is not equal to null, or even.next is not equal to null, even can even be odd.next, because odd.next is just even. The next element after odd is even. So you can do odd.next is not equal to null, and even.next is not equal to null, or you can do even is not equal to null, and even.next is not equal to null, whichever one works for you. I think this one is a little bit more readable, so I'm going to keep it. And in this while loop, we're going to do stuff. And what are the stuff we're going to do? We're going to do 4 operations. First operation is set odd.next to be even.next. Then we're going to set odd to be odd.next. That's the new odd.next that we just updated here. So set odd to this odd.next that we just updated. And then we do the same thing for even. So I'm just going to say do the same thing for even. So what are we going to do? We're going to set even.next to be odd.next. And then we set even to be equal to even.next. The new even.next that we just updated here. And at the end of the while loop, after breaking out of this while loop, all we have to do now is just set odd.next to be equal to evenhead, and then evenhead points to the first even, and this is the bridge that we're going to create between the odd list and the even list. Now, the only thing we have to do is to return head. Let's run this and see what happens. Awesome, it's accepted. Let's submit this, and it's successful. So that's how you solve this question, guys. If you like this type of content, please consider subscribing to the channel. Comment down below if you have something to say. Also smash the like button for the YouTube algorithm. Share this video around the community, and I'll see you in the next one. Bye-bye.